Minsky is very new software. It's less than 2 years old. It has one major programmer writing it, and I'm not quite certain how many lines of code are in the whole thing, but I'd be amazed if we have more than about 20,000 lines of code behind it. Now what that means is it's nowhere near as developed as a familiar program most of you might be familiar with, for example, Microsoft Word. Now that's a little question. People try to work out how many lines of code are there to make Word what it is. I have my opinion about what that might be, but as I say, at least a few million. Now, I doubt that we're at 1% of that. Maybe we are, but much less well developed. But you will find bugs in any software, and of course you'll find bugs in a fairly new piece of software. And what I talk about now are some of the bugs. Now that we're aware of, we're trying to get rid of, and a bit of a warning to you: if things go wrong with Minsky and there are bugs, report them. It's just a normal part of software development. It's simply impossible to write a computer program and guarantee there will be no bugs from the outset. I want to show you one that's still affecting us, and we're currently trying to get rid of this one. So I showed you this Lorenzo tractor in an earlier simulation, and on we go at this stage, still blasting merrily away. When I first tried to design it, I got this message. It says, not all operations are wired. Now notice it's the red circle which comes up to a highlight when there is a problem in a model, is around mathematical operators which clearly are wired up. So this is a bug, and we're not quite certain why it happens. It's something which we've got to find examples like this so that Russell can identify what's actually causing it. So when I reloaded that file, that's what I actually saw. Notice that all those things which are currently highlighted over here in the image I've taken as not being wired are indeed shown as not wired. So that one's wired up. Well, actually that one has lost both its input and outputs. So is this one. But notice this one here, which is not highlighted, actually has one of its inputs shown up. So that's somehow that error has happened. Now when I try to wire, watch what happens. If I try to wire A up to the multiply block that I know is there, boom, doesn't go to it. And equally for the Y, to this block, doesn't go to it, and the X doesn't go to it. But this minus sign, whoops, didn't want that, I want to go up there. Okay, you can see it's a mess. So how do you handle it? If that actually happens to you, what can you do? Well, as much as there are bugs, there can also be workarounds. So what I do in this particular case is I know that's causing me problems, just delete it, bring a new one down, and hope that wires up okay, which it appears to. And let's see, we know this one is also buggy. I delete that one, bring that down, a new one, wire that up. So y minus x multiplied by that. Looks like I've got that equation okay. Now clearly there's some problems down here as well, so I want to delete that minus block. Let's bring down a new one and wire b minus z up to there. Now obviously the multiply block is erroneous in other ways. It won't let me put something at the top. If I try to go from here to the top, it won't let me. We do use that feature, by the way, being able to put multiple inputs onto one multiply block. So there's a feature of the program that you can do that, but this obviously is a bit of an errant multiply block. So get rid of that, get rid of this block, bring down a new multiply block, whack that there, and now see if we can wire this up. Yeah, okay. And then up to there, that works. Again, same story there. So let's just delete this minus block, bring down another one, and then try to wire that up. That works okay. Now I know that all these ones, so there's a multiply block there, which is clearly not working. Get rid of that, bring another one down, and a multiply block here, which is clearly not working. Delete that, bring another one down. Let's wire them up. And notice I wasn't being particularly careful without the equation right, so I hope I have any more. Let's hit and run and see what happens. Nothing turning up on the screen there. Let's just resize that. That's because I'm in equilibrium. Let's just change the value of x here and make it 1 rather than, well, actually make it 0.1, make it nice and close to equilibrium, but the equilibrium is 000. Boom, there we go. Rather fast. I'll just slow that down a bit because I'm taking a large number of steps per iteration before I show things on screen. Let's make it smaller than that. And then you get the very smooth one. So that's a bug, but clearly there's also a workaround to it. If you find a bug like that, then what we'd like you to do is sign up to our beta testers group, which you can do through the log on page over here. We have discussions and mailing lists. So sign up to the mailing list to receive information about bugs. Let's just go back to the top level here. I am at the top level, sorry about that. And what you then do when you are registered is create a ticket. And so I can create a ticket here saying the dreaded not all operations are wired bug is back again. I made a mistake thinking it was back once before and I'd simply not completed an equation properly. So that's then stated inside here. If you click inside and see what I've actually said, that's the example I've given you here. I've made it part of the Petty Master, which is the release version that's currently on the website. We want to fix this particular bug up there. If it was a new feature, if there's something else I want to add into the program at a later stage, we put it into the next version, which we're calling the MUN level, and that's, for example, having labels, saving default file extensions, stepping forward by holding down the button on the step forward simulation. Oh, I haven't demonstrated that yet. Let's just do that quickly. Stop here, then I can do one at a time, but I'd rather be able to hold that down and have it run all the way through. So those are the sort of features we want to add to the program over time. Your help in both using the program and then reporting when bugs like this turn up, so we can actually go through and identify them and make it all work a lot more smoothly, we most appreciate it. What I appreciate most, however, is people's realisation that because it is an early piece of software, there will be bugs, and that is simply part of the development process. Later on, there'll be far less bugs, and it'll work much more smoothly. But at this stage, just be prepared. You may find it has things that don't work properly. Identify them, report them to us, and we can fix them.